Good afternoon, everyone. We do have a good amount of people joining us right now, so I think we're going to go ahead and kick things off right away. So welcome to the Databricks and CDR office hours. There's a couple links on our screen while you were waiting. If you want to view previous training sessions or more information about upcoming events and topics, you can visit those two links. Laura's going to be dropping those in the chat, so you don't have to copy that whole URL over. Okay, so just a couple of administrative announcements and items before we get started today. Please note this meeting is being recorded. Please stay muted to minimize interruptions and use the Zoom chat to ask questions related to our office hours topic. All meeting materials will be made available in the CCSQ DNA portal. Just a quick note and reminder to give us a couple days to turn those around so we can get them accessible and 508 compliant. And then just a note as well, there may be some team members who are going to be answering your questions in the Zoom chat itself, or I may be relaying those to Katie so she can answer them verbally. So that is how our Q&A will be working for the day. And so with that, I'm going to go ahead and stop screen sharing and pass things over to Katie so she can kick things off.
Thanks, Julia. Hey, I think you should be on my screen. Do you guys see the Databricks screen? And I'm
Yep.
putting the link to the notebook in the chat.
The screen says functions, design, implementation, and debugging.
All right. So welcome today. I'm Katie. I'm a senior data engineer on the user services team. I'm going to talk today about functions, how to make them, how to use them, and what to do when something goes wrong. So hopefully by the end of this presentation, if you're not already familiar with functions, you'll feel comfortable in maybe making your own or thinking about how you might want to go about using them in some of your day-to-day workflow. If you guys don't mind, give me a thumbs up if you are mostly using SAS. I'd like to get a sense if you guys are kind of new to the SAS transition, or if you're using Python or anything like that. Maybe give me a heart if you're using Python, because I didn't see any thumbs up. Oh, I think I saw one thumbs up. Maybe there's a little bit of lag. Sorry, guys. Yeah, so I'm seeing hearts and thumbs ups. Okay, so we got a pretty good mix of people, I think. And so if you have been using SAS, you may have used macros, and functions and macros are different. But if you've been using macros, you should have an idea of how functions work. There are a lot of similarities. And functions are useful objects. They allow you to reuse code, and this is true in Python, R, and Scala. This presentation is going to focus mostly on Python, but I do have some R examples. So if you've used macros, you probably know some of the similar benefits of using those that are similar to using functions. That helps you to maintain and update your code more easily. It's simplifying logic that can get kind of complex, where if you have a big bunch of code, it's a lot easier to break that up into functions. And especially for data users, the functions are really helpful if you guys are making reports, or if your team has a certain operationalization of a concept that you guys have defined, that you're all supposed to do the same for your reports and or your white papers, or things that you might be doing with the data. You guys can collaborate a lot easier if you have something that you can point to and say, here's our one thing, you can use this immediately. because I wanted to focus a little bit more on this part here where I have input, processing, and output. So if I'm jumping down, so if the screen jumps for you, don't worry about that. If you have inputs and outputs to your functions frequently, they don't have to have a specific input specified by you, and they don't have to output something, as in they don't have to return a thing. What I have on the screen here, let me make it a little bigger, is Spark.SQL, and I have a data, this is a data frame here, and I have Spark.SQL, and I'm selecting something from a table. And since this table is not very big, I'm not specifying a where or specific columns, just for demonstration purposes. This returns a data frame. So a macro does not typically return something in this way, where you can say, and it can, but um, not in the exact same way. So the Spark.SQL, you're returning a data frame. If you look at the type of thing for this DFEVs down here in the output, it shows that it is a data frame. And if you look at the type of data frame.limit, you see that also is a data frame. So this returns a data frame, and you can save it into something new. So I say, okay, DFEVs underscore limit and 10. So this just returns this data frame with only 10 rows. And the example that I'm using in this notebook is for that data frame is the electric vehicles that are registered in the state of Washington, and they can be located anywhere around the country. Most of them are in Washington in the data set, but it's all vehicles that are registered in the state of Washington within a certain time frame. There's several years, I think, included in these data. I did want to point out, sorry, I'm jumping around, I'm going back up a little bit, that some of the examples in this notebook are not sparkly R. The R examples, they're just plain R, and they're not distributed or anything. Some of the Python examples are just basic old Python. They're not distributed, but some of them do use PySpark. For example, the data frame with the Washington electric vehicles. So some of the examples are distributed and some of them are not. But you can input a distributed data frame, do stuff with it that still takes advantage of what Databricks can offer, and then return that PySpark data frame or Sparkly R to continue to use. So
No.
as you're thinking about the things that I'm talking about in this presentation, just think about, you have an input, you do something with it, and you have an output. That data frame dot limit takes a data frame in it. Well, technically, it does some processing to that to filter it to 10 rows, and then the output is a new data frame with only those 10 rows. So the things that you can ask yourself if you start feeling stuck is, what is my input? What do I need as the output? And how do I transform things to get there? In your programs, you have a lot of ins and outs. So if you're already using Python, you're familiar with this, whether you really realize it or not. Your input might be a CSV, or it might be one of the tables from the catalog. You do some transformations, you get an output, and your inputs and outputs may have many of them as you're going through. And also, I wanted to note, I encourage you to clone this notebook and play around with it. Read it at your leisure. Okay, so for the basic syntax for functions are, they can do a number of things. You can simply display things. You can change a variable or column value. You can return a value. Down here, I have the very basic, the most basic bare minimum you need for a function, really, to call it a function. You have this def keyword, you need your colon and appropriate white space. And then I added this keyword pass. And this is useful if you're working with a team and you guys are putting together different functions that are doing different things. You may have somebody who sets out some kind of notebook or a class, and somebody else is going to fill in, or multiple people will fill in these functions. You put pass, and so this function will do nothing. If I call hello world right here, nothing's going to happen. It's not going to do anything or return anything because of this pass keyword. The next example I have hello world, and I'm just simply calling it to print hello world. So this is how you call it. You have to define it first for it to be available to call, and then you can call it by simply using the name with the parentheses. And if there's something to put in the parentheses, then you would do that too. And here's the output. It's hello world. So this is the R equivalent here. In R, you have a function keyword. You have the arrow to store it into an object. And then you have your curly braces, and then print hello world. You can call it just the same way as you would with Python. And then it says hello world. So the input part of that input processing output is, in this example, we have a name. So we can take hello world and specify a name. So instead of just printing hello world every time, we can change it. We can say hello world with world, and that says hello world. And then we can say Dorothy, hello Dorothy, Scarecrow, hello Scarecrow. You can make your functions very flexible. This name, when you specify this name, it's a positional argument. It has to be there. So if I could also say name equals world up here, and that would make it a keyword argument that has a default. And then I wouldn't have to say world. I wouldn't have to specify world. I could just get rid of this part, and then that would output the exact same as what you see in the output cell. And here's the equivalent example in R. You have your function keyword, and this is where you would put that positional argument name. So the output part is the return keyword. When you're working with PySpark, now we're back to the example that I showed you earlier with the data frames. You return things. So as I said before, both of these return a data frame. So a lot of the things that you do with PySpark, if you've already worked with it, you're returning things, and you may have done data frame dot group by dot count dot something. You may have a whole bunch of things chained together with this dot notation, and that is really helpful. It's really helpful, and then you are returning something each of those times. So a group by returns a group object, which you have to do. You can only do certain things on that, but that's just something to keep in mind. That's that input, data frame, output, group object. And then the group object is an input to count or something like that. You can bring in a function. Sorry, I'm back down here. In a function that you define, you can input any object, and everything is an object in Python. So you can input a string, you can return a string, you can input an integer, you can input another function, and that is a very interesting and useful thing that we won't get into today. But you can input an object like a data frame, a PySpark data frame, and return it. So that's something that a lot of the PySpark package has available for you to do already. And in this example, instead of doing a print, I'm returning a string. So I could print hello world, where in the output here, I've got hello world and hello world. So I get the same thing returned both times, but I'm doing it in a little different way. So earlier I got the same thing returned, but this was print hello world rather than return. Because I'm returning text here with this function is equivalent to this text. And that's what this example here is trying to show, is that kind of, if you think about it as this is that, because it is returning that, then that, I always found that helpful when I was sort of first figuring out how these things all kind of fit together and relate to each other. In R, you can also return things. In this one, in R, you have a little brackets around your stuff. But the down here, to actually use it, it looks the same. Hello world and hello world. You can return a number. Here's an example that has inputs, and I use them in my return statement. So I have num1 and num2, and I return num1 plus num2. So, okay, I want to print, add numbers 2, comma 2, and then that gives me 4. And now R, it's very similar. Function 1, 2, return 1 plus 2, put it into add numbers with your little arrow, and then you can use it in the same way, and it gives you 4. I also wanted to mention in Python something that is interesting that you can do is you can return more than one thing. If you have used the pyreadstat package, you may have noticed this returns two things when you read a SAS data set, and I'm pretty sure that we can't use pyreadstat in Databricks, but if you've used it outside or locally or something like that, it returns a metadata object and it returns a data frame of the SAS file. So you get two things when you use one function. And down here I have a very simple example. I called the function return two things. For the example, I'm inputting a list. I get a total by summing the things in the list, and then an average equals the total divided by how many things are in the list. So then I can return total, and I like my integers, so I'm returning an integer of that average. And the way that you use that syntax here is you could say total comma average equals, because it'll return in the same order that you have it in the return line. Say I return two things with 1, 2, 3, then the total is 6 because 1 plus 2 plus 3 is 6, and then the average is 2 because 6 divided by 3 is 2. And the next thing, it might feel like we're ratcheting this up a bit by talking about this next thing. There's positional arguments and keyword arguments. And in Python, these are really helpful, and you'll see these in a lot of places. Whether you end up using them or not is fine. So if you have used print in Python, you have used that positional arguments, those args, star args, and you can enter as much text as you would like. I can enter a number of strings. I have 3 things going into print, and it prints those as one thing in the output cell. So I could have more, I could have less, and it will still print them. And I don't have to say string 1, comma, string 2, comma, string 3, and limit myself to 3 things. I can say star args and take in a whole bunch of stuff. The keyword arguments are where you have something equals something else, where you have a name, a key specified for something that's going in, and a value specified for what that key corresponds with. So for the keyword arguments, I think string.format is going to feel familiar if you have used f strings. Because the f strings look a lot like this first line, but they'll have an f in front of them. So the way that you use this thing is you have a template. For example, hello, comma name, you are age years old. The formatted string using that template is template.format, and then you enter all of your keyword arguments. And this can take as many or as few that you want to specify. So just as a fun example, it's just an example. Hello world, you're 4 billion years old. So you can enter, hello name, your age. You could also put, instead of years, you could say time or type or whatever, and you could say, hello Luke, you're 8 months old. You could add that in here and that wouldn't break anything because it allows you to be really flexible and add as many or as few of these keyword arguments as you want. And R has sort of an equivalent where there's this ellipsis parameter that allows you to enter many things, but it does not have that keyword equivalent. So here's the example for R. I've got a vector coming in. Basically, I want to sum all the things in it. So the expected output, 1 plus 2 plus 3 plus 4 is 10. And then this next one, 5, 10, 15. So I have 4 things going in here and 3 things going into the second one. And it doesn't have an error or anything. It lets me put in more or less, and it still works. And I was trying to think of a good example, and this next example is maybe a possible use case that you guys might want to, just to help you think about what might I use args or keyword args for. So if I want to use matplotlib and plot some things, and this function could definitely use some tweaking, but just to think about it, if your args are data frames and your keyword args are all the different things that you can enter for a plot, let's say you have a list of dictionaries in Python and you can say color key blue, label key title, or title, maybe a title key, which is what I've got here. So I'm reading in a title and I'm saying I want it to be, something. And you can say, okay, plot type is line. So if plot type is line, then it'll do these things. You may want to have something within here that says, if this keyword exists, then do this. Or maybe you could enter, some kind of dictionary here in some way where you can, make it a little more flexible. But it's a potentially a real life example of something you could potentially do with these things that actually relates to you guys if you're doing graphs and charts. So if you, for example, maybe want to do all of the different things that you have to check before you do a regression, you could do a function for it. And you could do a function for it whether or not you use args or keyword args. You could, I'll show, I have another example of kind of a thought process of how to create a function. But this is just a potential example. So to put all of the hello world stuff together that we've talked about so far, I have an example. I have one positional argument name. I have the args for some varying things that could go in here. It's just going to be text in this example. A keyword with a default, and this default greeting hello means that I don't have to specify greeting, but I can change it if I want to. And then quargs, as you might hear it called sometimes, keyword arguments can go at the end. And in this example, I just have them printed. So let me show you really quick what the print looks like. So I've got hello world Alice, and then it prints hello Alice, because hello was the default greeting. I'm changing greeting equals hi and name equals Bob. Hi, Bob. Then we have, hello, Charlie, welcome to the team. So Charlie, and it uses the default hello greeting. And then these are positional arguments. These are the star args where you can add some message, something to this message. And then this one, hey, David, pet equals guinea pig, hubby equals ham radio. So you could specify those keyword arguments and then they get printed last, just as a key colon value. And then you can put everything in there together where you have a name, the positional arguments, greeting equals hi, and then you have 3 keyword arguments here where you only had 2 above. So the function itself takes in those things that we talked about, and I'm skipping over this right here. We'll talk about it in a moment. It stores this into a message equals, this is an F string, greeting comma name, exclamation point. So hello, Alice. If there are any extra positional arguments, then if they exist, we add them together. They're joined with white space, and it starts with white space so that there's something between that exclamation point up here and your our positional arguments. And if there are any keyword arguments, then you add those in there too. And this is kind of like a dictionary comprehension sort of thing. So if you can do this for key value in your, which is something that is basically a dictionary, dot items. So key colon value, and then it returns that text that you have built up all together so that you see it down here. And I wanted to tell you about this. So I have to run this to show you help text below, but to explain what this is called a doc string. So this three quotes on either side of it. This is something that you can put into a function or a program or a class where you explain what it is. And there's different formats. You could use your own format, kind of like, I don't think this follows any particular format. But there are different ones. And just as long as you make it clear what is this function, what does it take in, and what does it return? So this is, I'm saying it's a simple function that demonstrates different features. So I have a positional argument, and it basically what we talked about before. What are the things here? Because that's what this function is meant for. It's meant to demonstrate that to you. And then to explain what the arguments are here, it's a string. So you want to specify, like, what is it? Is it optional? Does it have a default? This defaults to hello. And then keyword arguments to give a description of what kinds of things are expected to come in. Even though it's very flexible, you may have something that handles it down here where you need to let the user of your function know what they should enter. And then it returns a string, which is a greeting message. And then below, I have this help text. So that doc string turns into, if you have to be connected to a cluster and have run this so it is available in memory. I'm hovering my mouse over it. I didn't even, well, I clicked at the front of it. So it tells me all that stuff that we just talked about in the doc string is right here. And I can put my mouse up a little bit and scroll down, scroll up, and it shows you the information. So if you're connected to a cluster, and you can do this with other things, so you can also use the keyword help, or the function help and that will print out in your output what the doc string says. You can also use it on existing functions that you might use for PySpark. So if what does when's documentation say? So it gives you this information. This kind of looks like restructured text format. I might be wrong about that. And it tells you an example, which is really nice. So sometimes when you do this, you won't get anything at all. It can be a mixed bag. So sometimes the website has better documentation than these do. And sometimes it's the same because you can use this. You can use those doc strings to create documentation, and a lot of people do that. And then the R example is very similar. It does not have that keyword argument where you can specify. And if I'm wrong about that, somebody let me know. So you have pet equals null and hobby equals null. They don't have to be there, but if they are there, you can specify them. So this greeting equals hello. That's also a default, but just like we had above. And the ellipsis is here. And I'm not going to go through this one in detail. It's very similar. But one thing I will show is I had an extra example here where I say print hello world, Luke, how are you? Greeting equals hey. And that's one you can specify. Pet equals sugar bear. That's something you can specify, but movie, color, and game are not. So they get caught in the ellipsis. And then it says, hello, how are you? And then it prints the values. It didn't print the keys, it just printed the values of these keywords that we put in, but they were not ones that we specified. So if we did not have that ellipsis in there, I'm pretty sure it would give us an error or an exception where it would say, no, you can't do this. So in R, you can also do help. So here helps for the square root. So here's what square root looks like. And there's a lot of stuff that prints out. And then you can read that. You can also use the question mark and then the name of the function or object, square root. The next part is when you want to use a function in your program, there are different ways you can go about it. And one of the things I did want to also say is if you want to make functions, I just encourage you to start trying it, start typing, start coding, give it a try, because that's the best way you're going to figure out how it works and what sorts of things you want to do with it. It's okay if you have a function that's too long or has too many parameters passed in. If you have too many parameters passed in, like if I had this example up here that we just looked at, if there were like 8 things across here, then I might think to myself, I think I need to pass in an object or maybe 2 objects instead of 8 things, because that is also kind of difficult to maintain and keep track of. And if you have to make changes, that can make things really complicated and tedious, and it can make it difficult and prone to errors. So I recommend if you can think of a good way to group things into objects and classes, which we're not covering today. I just wanted to kind of mention it so it's in your brain that there are cases where you would want to pass in a custom object or something else instead of many things. And so to make a function, it's okay if your functions are way too long. If you're just starting out, as long as it's something that's helping you, it's going to help you avoid copy paste errors and help you code faster, maybe help you code more efficiently, so that if you're sharing things with each other in your team or across teams, then it can be really helpful to have functions where somebody says, oh, I figured out how to do this really quickly. Do you want to take a look at it? Maybe it works for you too. Another thing that we have in Databricks, which actually exists in notebooks, is the %run. It's not exclusive to Databricks. So in this %run example, I have a notebook that I use for a recent lunch and learn. It's here. So I have functions in this notebook, and I click to the notebook, so I'm scrolling down to the main function that I'm going to talk about, which is this compare. So I have defined this compare function, and then if I click run, it will show me the markdown text that I have at the very top. This markdown text explains 3 of the main functions that are in there and what you can do with them and how. So if you wanted to use this notebook, you would need to specify this full path where it's in that CDR PSA community. And then, you can use these if you feel like they would be helpful to you. You could take them and you can make something different if you think, oh, this isn't going to fit what I need, but it's almost there. So %run is one way that you can bring functions into a notebook from somewhere else. Another thing is that notebooks are really helpful to just to use as something to share with your team, where you have a bunch of code that runs and you can interact with it and everything. So I know a lot of teams are using notebooks to share reusable code, and that's fine. We have that available to us. So %run is good. I want to comment that, remember, %run has to be the only thing in the cell, nothing, no blank line under it, no comment above it. It has to be the only thing in there, or else it'll tell you something like you don't have permission. But that's not exactly it. It's just, this has to be the only line in there. So next I'm going to use the compare function just to show you, oh, it's in this notebook now. From in there. We didn't define compare in here. I'm taking that Washington EVs data and I put it in a data frame. I'm going to add this high MSRP column just as an example. If something is over $50,000 for its base MSRP, we'll say true, otherwise we'll say it's false. So that adds a new column, and this compare function will take the first data frame, the second data frame. I'm going to give them the names of original and compare. So data frame _ EVs is original, and the second one that has this new variables compare. The function takes that in, it does these two prints for each data frame where we have the same number of rows. This one has one more column, and that's what we expect because we added one. If there's one column that is in the compare one and not original, high MSRP, and because that is the case, because there is a difference, I have this print down here again, just for grins and giggles. There's also two other things. I won't go over this in detail, but if you revisit that lunch and learn on data validation practices, then I talk about what these are in there. And it's also is in this compare notebook. And there's some comments to explain it a little bit. You can define functions in your notebook. So you could call them in with %run. You can also just define them in your notebook, and that's fine. If I have a notebook where I want to get data frame info every time I get a new data frame, PySpark data frame, then I get the number of rows, the number of columns, and these column names. And this is another thing that I wanted to mention because I said something above where I say you can change, use functions to change the values of an object. This example with where you have a data frame dot columns, that is an attribute of the data frame class. So this PySpark data frame, say this EVs is an instance of the data frame class, and it has a dot columns attribute. The way that you change that, you don't change it. I think you can, but because Python allows you to do that sort of thing, is you could change it directly, but what you're meant to do is change it with the functions like drop or adding with column and adding a new column. So you change the things in the object with the functions that are in that object. So data frame has lots of different ones that my colleague Chris has a good presentation on Intro to OOP. He shows how to read the documentation also. The link to that is at the bottom of this notebook. So I'd encourage you to go look at that if you're interested, or maybe whenever you get to that point, to look at objects and classes. Learning how to read documentation, learning to see all of the different things in data frames, even if you use data frames all the time, they still add stuff and you may miss it. So if you peruse the documentation every once in a while, you might learn something new because there are so many things in a data frame class, so many things that you can do. But you might use only a few of them very frequently. I know I do. So that's an example of using the function in the notebook and defining it there or here. And that's what we've been doing throughout this notebook. So you've already seen this. So to make your own new function, I have an example here of, here's some code. You might have code, and this is an example where we're going to step through how are we going to make this code into a function? How are we going to think about this? So I might have this bit of code. Maybe I use it very frequently. Maybe I have a lot of things where I need to get an age, and maybe it can be very general like this, where you have 1 year minus another year. Maybe you have a lot of things where you have a date of birth, and because in the surveys that I've worked on, a date of birth was often a very complicated edit that you had to do. And so putting that into a function was a way to standardize the definition of how do you code date of birth or age based on all of the information in this survey, knowing all of the limitations of, all of the things involved. But in this example, we just have 1 year minus another year. This is very simple. But if you have something like age is a good example of one that may lend itself to being in a function that you guys share together with your team. So I look at this, I have filter, filter, filter. There are 3 things here that are filtering data frame, and I read in the original one. I return this data frame with county. And so let's say interested in King County, which I'm pretty sure is the county for Seattle, that returns into this new one called filter. And then I use that to filter by electric vehicle type. And let's say I'm interested in plug-in hybrid to see what that looks like. And the electric range greater than or equal to 100. So if you take those and you want to know what is the most frequently registered in the data, I think it was like some kind of BMW or something. And then after that, we have something where we create a new column of age, and then we create that high MSRP that we saw earlier. I want to break them up into two things. And I'm just calling it function 1 and function 2 just to start with, because I'll get a meaningful function name when I'm exactly sure what I want to do with this. I know I want a data frame to come in because you have to bring it in to return it. Otherwise, it won't know what it is. So in this example here, it doesn't know what this is. So it's not going to do anything with these here. Well, actually it might, but you don't want that. You want to bring in this data frame to come in, and you want it to go out after it has been changed. And in this function 2, I put these transformations. So I have filter and I have transformations happening. The next step, I say, okay, I've got my data frame, and then I want to make sure that that's what my data frame is called in the function. That's one of the things that you can do to debug. There's lots of very simple sanity check types of things that you want to do to debug. And this is one of them. Did I actually call my variable the right thing within my function? And did I return something? Because right now, okay, we're filtering things, but we don't return it. So it's not doing anything. You may see if the data frame doesn't exist initially, it might tell you, oh, this doesn't exist. If you're trying to do something with it and you have a column that you're creating, oh, it will say, where's my column? And you'll say, oh, but I thought I was creating it in here. Let me check and see, did I return a data frame? Oh, I didn't. So if you add that in there, that may fix your problem. I decide, let's say I decide also that I'm going to go back up here, that instead of always specifying King County or always specifying plug-in hybrid or this particular electric range, I can make those flexible. So I can put whatever county I want, whatever vehicle type I want, and whatever minimum electric range. I could be interested in ones that have 60 or above, or 1 or above, or something like that. And then with the transformation, maybe I just want to make the same variables each time. It doesn't matter exactly what they do. So then in the next thing, we add the return, because we want to make sure we return something. Input does something, output, and that is very important because, like I said, it's not going to do anything if you don't tell it to return it. And it won't know what stuff is if you don't specify it in your function call up here. So in the lastly, maybe I'm only interested in forcing county. So I always have to specify a county to make sure that I filter my data. And then maybe vehicle type is optional, and a minimum electric range is optional, because here we have it set to none. And that means you don't have to specify it at all, but you do want to make sure if you have these sorts of things that you check for them. So because if you just had dataframe.filter with the minimum electric range and that was none, it's going to say, oh, I don't like that. I'm going to throw an exception. I'm going to complain to you about this and give you an error. For county, this is probably a problem that I would not want to have, where if I didn't specify county, this might be okay with that and still just return you the data frame, and you wouldn't realize that happened. If you didn't specify it, it would complain to you, because it says it needs it up here, so it should expect it to be in any call that you make to it. And then the transform vehicles, I didn't really do anything with that either. So I also gave both of them doc strings. So here's another example of doc strings that you can look at. And now I'm at my very last section. If anybody has any very interesting ideas for functions they think would be helpful, maybe enter it in the chat. So you guys can help each other think of ideas for functions that maybe somebody has an idea of one that everybody else, could benefit from. If you don't mind, if you feel comfortable sharing that in the chat, go for it. And I'll keep talking. I've got debugging functions is the last section. So when something goes wrong with your function, what do you do? The thing that I recommend is that you use prints. Databricks does have a debug function. I don't recommend you use it just because our data can get so big, and I think it's going to cause issues. So if the print statements are going to be your best friend for this. The other thing about debugging is, as you see in this notebook, and I've seen in a lot of notebooks that from doing help desk and stuff, so people tend to make their cells do one thing. You want your cells to kind of do one thing, and that also helps with debugging. So if you get to a certain point, you're able to stop right there and do some data exploration, and then you figure out what's wrong with your program or with your function or a cell or something like that. The notebook naturally has breakpoints, and that's one thing a debugger will do for you is it has breakpoints that you set for a .py file, for example, that runs and it's very long, and you don't want to run the whole thing every time. You want it to stop so that you can check what's happening at certain points and what variable values are at certain points. I have a list of some of the common pitfalls for debugging and about debugging. So you might have error messages that tell you what's wrong and where. Sometimes the error might not be helpful. It might not specify the location of the problem. Sometimes it does. And usually you'll be pretty lucky. It'll give you a line number. But sometimes error messages are not that helpful, and you're going to have to do prints to find out what's wrong, and you start investigating and doing your detective work. It's also important to note in environments like Databricks, error handling can be more complex. The Python code or R code that you submit is transformed into something that can be read by an underlying JVM. That's a Java virtual machine. Scala is the language that this is all kind of the foundation of everything that's happening under the hood is Scala, and the everything has to get translated to something that virtual machine can read. So that can give you all these errors that sometimes don't make any sense to you, or maybe it just seems like it's so far removed from your actual problem. So keep that in mind. And then when you have lazy evaluation like Spark, you might have an issue in one place and then your error message points somewhere else, because it's very difficult for whenever it takes your code in, it can it can optimize it, and sometimes that means it shifts things around whenever you actually make a call that executes your transformation. So you have transformations that are logged, you may have a whole bunch, and then you call display or collect or something, and then that makes them all happen, but they may not all happen in the order that you put them in. So that's just something to kind of keep in mind. Then so these common pitfalls are basically sanity checks for things that I've run into. Windows line endings in Linux shell. So if somebody's working in Windows and runs a Python program in Linux without checking that their white space and line endings make sense, that can be an issue. So I'm very quickly going to go through this example using a print. I have from built-ins import sum. You normally don't have to specify this because it's built in as it says, but because PySpark, it is looking for that first in this environment, and it gets really confused. So I'm importing it explicitly here, and I'm also saying import functions as F, so I'm not importing sum anywhere. And I had to do both of those for this to work. And I really wanted to give you just a simple example that makes sense and has numbers in it. So if you calculate an average, you say your total sum of your numbers and you divide it by the count. And we did that up above. That returns an average. and that works fine. 1, 2, 3. We print that here, and then we do it, and then the average is 2. However, the problem comes if we have a blank. So we encounter an error. It says 0 division error. So this one's actually kind of helpful. And it says division by 0. Next, I put inside the function, I put print. So this is the exact same function. I just copied and pasted it. And I do copy and paste my functions again if I'm debugging something, just so I don't mess it up too much and then get lost. But let's say I print what you want to know, the value of your variables when you're here. And when you print it, you have the input as an empty list. It says inside the function, it says input is this, length is 0, sum is 0. And then I say, oh, division by 0, my count is 0, which I'm calling sum here. And I know that because I put it in there. And then, oh, I can't divide by 0. So that's probably my problem. And then I would fix this by saying if count is greater than 0, then do this, else do something else, however you want to handle that. In conclusion, we covered the advantages very briefly of using functions. I hope you go and read that again. You can collaborate, standardize, make your code readable, easier to read, maintain, and manage. And then hopefully you understand function basics and you maybe feel comfortable, if you haven't before, starting to create your own functions. Maybe you understand how functions are working a little better while you're using them, and debugging functions. We also went over that a little bit. I've got resources, and there are a few exercises that I put at the end. Feel free to do those when you have time, if you're allowed. And let us know if that's something that you like or not. We're gonna give you the survey soon, so if you would like exercises at the end of notebooks, let us know that. If you saw anything in here that you wanted to see a presentation about, maybe let us know that in the survey also. I really appreciate you guys coming, and please fill out the survey. Back to you, Julia.
Thanks, Katie. So thank you to Katie and everyone who joined us today. We had really great participation numbers today, so that's awesome. As Katie said, we are going to be administering a survey right now. Okay, it should be up on your screen. Just take a couple of minutes to answer the questions to make sure that we continue improving our offerings and make sure that the trainings continue to be beneficial. And as Katie said, any other feedback or questions you have. And then please feel free to drop the meeting as soon as you've submitted the survey. And thank you again for joining us.